Hello. So in this final project of mechanics of material, we will analyze roller coasters. The problem definition: object to analyze are roller coasters. Loads applied are rain, snow, wind, and all sorts of other conditions. Problems observed due to these conditions are they lose their friction due to cold weather, heavy rain causes sensor malfunctions. This is a typical shape or design of a roller coaster which is made of steel. Roller coaster is a machine that uses gravity and inertia to send the train or cars along a winding track. The combination of gravity and inertia, along with g-forces and centrifugal acceleration, gives the body certain sensations as the coaster moves up and down around the track. When going around a roller coaster's vertical loop, the inertia that produces a thrilling acceleration force also keeps passengers in their seat. Usually, roller coasters are made of steel, because of their high uh, stress and low bearing capacities. Usually, the structure of roller coaster is a crisscross steel design. One example of a roller coaster with a mass of 500 kg when fully loaded with passengers is given in this diagram, which has a speed of 20 meters per second at a point A, and we have to find what's the maximum speed of the vehicle at point B for gravity to hold it on the track. This is a SolidWorks beam with a point load. Just a part of this diagram shows a roller coaster with whose small part of a roller coaster is taken into consideration and a load is applied in the center, and it shows how the deformation in the roller coaster can happen if the load applied is too much than its bearing capacity. Maximum load on the small beam of the roller coaster can be found out using this formula of deflection equals PL cubed over 3EI, where E is the modulus of elasticity of steel, length of the structure is L, I is the moment of inertia, and the deflection is given. The formula and therefore we can conclude that if given a small part of roller coaster whose length is 100 meters, the maximum load applied on it can be around 3,000 kilonewtons. This is just an example of a smooth beam in a roller coaster. The roller coaster also experiences stress, strain, and deformation under load. This is a diagram which can show the maximum compression in the beam if the load applied is more than its bearing capacity. The stress, strain, and deflection of any given body is given by these formulas. The stress is given by force upon the area of cross-section of the beam. Strain is given by deflection over length the or the change over the length. The acknowledgements and references are given from these. Thank you.